Good morning, and I'm back to work again, and a good night's sleep has sweetened my disposition. So continuing with the project, I have this set up on the Bridgeport here, and I'm just using a 1-inch end mill here to provide the clearance for this boss. It's already laid out and it's centered in the y-axis, so let's go to work. All there is to that. 30 seconds worth of cutting and 30 minutes worth of setup. Alright, and about 30 seconds worth of sanding right there to allow for a little relief on Palmer's belt sander. Looking pretty good. Now comes the hard part. This is the gib side. The gib side is a little bit less in dimension here. It's 0.785, whereas the other side is 0.858. So this entire slot or dovetail here is not really centered within the casting. So I will carry that theme on into the aluminum part. And we need to measure, and I've shown this before, a dovetail. And there's only one good way to do that. Well, there's probably many ways, but the way I do it is with round rods, and in this case they're 1/4-inch dowel pins, and the diameter isn't too critical. There'd be a wide range that would work within this dovetail, but the idea is to lay the, I'll move this out of the way, falls like a house of cards. That's the idea. So the dowel pins have to be at least a diameter of such that they are exposed. Now I can measure, but actually I want to measure, well, two ways. I'm going to take a measurement without the gib and a measurement with the gib. And I like to use the Brown & Sharp adjustable parallels, but of course you could just use caliper and it probably would have been okay. Matter of fact, it would be okay. I'll rock it a little bit to find the center, but I'm going to use the adjustable parallels, and I've already got that set pretty much for the gib being in place, so I'll go back to that, put the dowel pins in place, and believe it or not, there was a screwdriver in the kit, the Brown & Sharp kit, and it can be snugged up a little bit. That way I can maintain the measurement and take this part even over to the milling machine if I have the urge to do that, and that can then be slid out like that. And take my measurement off that, and I will write it down either right on here or on a piece of paper. It doesn't matter, but that dimension, wow, that comes out pretty even. It's 1.300. Easy to remember, although I would forget within seconds. I already forgot. Okay, so that's the game plan, but now I'll do a little bit of layout on here, and I'm going to take just a regular end mill to start with and form a rough slot to the right depth. And I've checked the depth also with my, I think it's a shear Tomiko. Yeah, my shear Tomiko. Depth micrometer like that, and I have written that down before. That's 0.350, also a rather easy to handle dimension. So I will make a slot that is about 300 and 25 deep and a little less wide than this, whatever that is. And then I will go in there for the kill with the 30-degree dovetail cutter. So a little layout on this which I will not show you, and then over to the mill we go. And one other thing. This dovetail actually is going to be a blind dovetail. That is, I'm going to come right up to about where I got that black line. Later on, this may be reduced in thickness. I haven't decided yet. But that will come to a dead end right about there, or it could be a little bit less. So that's what that black line is for. So really, when you do something like this, you got to give it a lot of thought. If you don't, you're back to square one. Here's the setup. You can see the layout lines, and those are just rough lines, and I want to make a slot that is 350 thousandths deep, and this is a 3/4 end mill, and just up to the confines of those lines before I switch to a dovetail cutter. And then after I get that down to depth, I will also take just a skim cut off of these two ends, but for now that would take my layout line away, so I'll save that for later. Here we go, 100 thousandths deep on the first pass. Making a little progress. I jacked up the speed. It was way too slow, the spindle speed, and with this pass I'm down to 300 thousandths in depth. Notice that I took a skim coat off of both this side and this side to bring it into compliance and parallelness and all of that with the bottom of this slot. And with the final pass here of taking off 10 thousandths more, I'm down to within 10 thousandths of the final depth, which I will take with the dovetail cutter. As you can see, the slot has been roughed out to approximately the size of this, less the dovetail. Now, I suppose if a fella had a notion he could do everything with the dovetail cutter, but I'm going to switch to the dovetail cutter now and take it to the final depth, which is about 10 thousandths more, and then to the final width, and that's when I start using the dowel pins and the calipers. And now the final 9 thousandths in depth with the dovetail cutter should bring it to the final dimension depth-wise. And there it is within about a 1/2 thousandth. So that knee adjustment will remain the same now through the end of the video, or the cutting. I've taken this side down to the width that I want here, and I'm taking a initial reading here using my homemade gib along with the 2 dowel pins. Can you see them there? And I'm just using this. My final dimension needs to be 1.300, and that will all be taken off of this side now. So the approximate measurement here, just with the caliper at this point, is 1.252. So I have approximately, what, about 48 thousandths to remove from this side. I just took another measurement and I'm within 5 or 6 thousandths, so I have increased this feed here in the y-axis by 5 thousandths, and then I'll clean it up good and measure it. That might be the last pass, maybe one more to clean it up. After all, there's just a little tolerance here because, you know, that's what a gib's for, after all. Okay, did I mention that I am climb milling for my final passes to try to achieve a good finish? Doesn't matter so much on the gib side, but remember, this is going to make metal-to-metal contact on this side. It is with great fear and trepidation that I take my final cut and then a measurement. Makes your heart thump a little bit, but there are the 2 dowel pins, and I got a good fit here with the black and brown and dull. I almost said Black and Decker. With the brown and dull adjustable parallel. And let's see what we got. $298.5, so I'm 1.5 thousandths under, but I think that's going to work just fine. I'd rather have it just a hair loose, because when I take this out of the vise and then I'd make a test fit over on the actual cross slide, there really isn't any returning it to the machine here. The only possibility would be to take the whole vise off, which weighs 75 pounds, and try to fit it up. But of course, I'm not going to do that. That's foolishness. So I'm done, and I'm going to take it out and we'll have a test fit. Again, a great fear. I'll be pouting all afternoon if this doesn't fit, but it should. I mean, the dimensions were what it called for. Notice that this is the blind dovetail that I talked about. That could be milled off. Let's see if it fits. Put it on this way, and then I'll put the gib in. Makes more sense, doesn't it? And it slides right in. It felt just a little tight. You know, I didn't oil it. I should have oiled it. But I couldn't wait. Boy, that's a nice fit. Wow. Shoot, I got a good fit without any gib screws. Maybe I should forego that effort. Yeah, I don't feel really any of this at all. All right, that's too good to be true. So in fact, you know, I still have a little milling to do to make this boss here slide under, so I have to measure that, and then I got a slot to make, and we got some holes to drill, so still got half an afternoon's work, but I'm so happy that this fits that I'm going to reward myself with some lunch here presently. See you when I have a full gut. So this is how it works. Now, on the original Logan equipment, this was all one piece, and I had to make it up with 2 pieces. We still got to have 2 holes here. I guess I just mentioned that, and that will follow. Now, this block here at this time will not fit under. This casting is too thick right here. So to determine how much I need to take off of the bottom of this, I measured. This is not a blind hole, it goes all the way through, and that was 475 thousandths. Similarly, I took a parallel and measured underneath here, which was 398 thousandths, and do a little math there, and I need to remove 77 thousandths. Then this will slide under and I can make my slot and bolt it down. And here I am taking the 78 thousandths off. And now drilling the 3 gib holes, and I'll have to tap them, but I've already drilled that 1/8 inch hole that is the pin that holds the gib in position. I'm getting near the end. Thanks for staying with me. So I've milled underneath here. You can see that slides with a pretty decent fit. Now I need to mill a 3/8 diameter slot that will allow me to fasten this to the slide bar back here. Some lathes have a lever there rather than a bolt, because depending on the diameter of the work, this may have to be moved in or out, and that final position is determined upon working with it, I guess you could say. And then I got 2 holes to drill here, like that, and I've already transferred those with transfer punches, so when I take that off, should be ready to go. And I have snugged up, probably can't see them, the gibs. So it's looking good. I'll go over to the mill and put that slot in, right in the center of this elongated boss. And finally slotting out. And ready for a test fit. Almost done. So what I've done, of course, is to take this off, and normally when I'm not making a taper, I'll take all of this off and just put the chip cover back on. But in a moment I'm going to put the compound rest back on, and I have oiled this bar. That's pretty important. And again, there's gibs on the back of this slide. And when cutting a taper, a person will tighten this down. I'm going to need a thicker washer in there. I'm already bottomed out, or a shorter bolt. What I was going to say besides that is that I have to take the nut screw out of here, because I do not want to operate the hand wheel. All of the movement of the cross slide will be determined by copying or following this bar at whatever taper it's set at, and the graduations out here are in taper per foot, not degrees. Some of lathes have both graduations. This one does not. So let me get the right bolt here and put the compound on, and we might even take it for a test run. It wasn't my purpose to give a demonstration on taper turning, but now with the binding screw back here tightened and the screw that holds the cross feed nut removed, all of the feeding has to be done with the compound, and I brought the tool in fairly close, so the taper gauge goes in about that far. But watch what happens when I move it down. Right here, the taper gauge goes in that far. So I am producing a taper. Let me take one or two real light cuts just to show you. And I am using power feed. And it will stop cutting momentarily. And that's the end of the taper. So here's the piece I just turned, and you can see that it's tapered. That's the reading at the end, and as I go up further, it's larger. So that's what a taper attachment does, and you can use power feeds with that. So that about brings this video to a close. And what I've done here is I've gone from my wooden Think About It model, just out of scrap wood, to a pattern, to a casting. Well, I won't need that. And that concludes this video. I hope you enjoyed it. Now, there will be no one in all of Christendom that will need to do this, but the video showed you so many different operations that you can do in your shop on your project. So I hope you enjoyed this, and this is tubalcain saying so long for now, and be sure and watch me in my 950 other shop videos. See you soon.